Hi everybody, welcome back. I'm going to do 2 videos today, and what we're going to go through is where does root 3 come from? Where does that relationship actually come from? So we're going to do this, and I'm going to show this not using the degrees, but actually using some of the fractions to show where this value of root 3 actually comes up. So I'm going to break this into 2 videos. The first is just a description of these 2 vectors or these 2 phasors that we have. And then the second one will actually specifically be where does root 3 come into play. So if we have 2 phasor here, and let's say that this length of this phasor is 1 unit. You could be 1 volt, 1 ohm, 1 amp, 1 centimeter. If you're doing physics stuff, it could be a unit of force, okay? But we're just going to say that that's 1. So that, if I broke down, that's its length. If I were to break down its horizontal and vertical components, its horizontal is all of that, and its vertical component I could describe as 0. There's no vertical component that goes with it. If I took that exact same phasor, okay, and I added another magnitude at this location, if we were doing this properly or not properly, but if we were doing this in degrees, we would know this is at 60 degrees. We're not going to do this in degrees. We're just going to break this down into horizontal and vertical components. So it's the exact same magnitude, meaning the length of this phasor is still 1 unit. And at this point, what this horizontal component is, based on where it's shifted, okay, I've shifted this phasor so that its horizontal component would be 1/2. That means the length of its base right here is 1/2 or half of the magnitude of this. It works out as half because we set this as 1. If this was a magnitude of 120, then its horizontal component would be 60. But we're going to leave this to actually kind of get to where root 3 is. So what I need to know now is I need to be able to determine, well, if this horizontal component is 1/2, the length of the hypotenuse is 1, what does this vertical component equal? What is its y component? We can use basic Pythagorean theorem to actually come up with this. So I'm just going to use 3 values for the Pythagorean theorem. I'm going to say that z squared, I'm going to say that's my hypotenuse, is equal to x squared, my horizontal, plus my vertical, or y squared. So what we're trying to figure out is what is the actual value of y. So after I transpose this, it would be y is equal to the square root of z squared minus x squared. If you're going to follow along and you're like, Jason, a squared, b squared, c squared, it's the exact same thing. This would be c squared. This would be our a squared, b squared, or b squared and a squared. Okay, if you need to follow along like that, there's absolutely nothing wrong with that. So what we have now is we have the square root, and I like to put this in brackets just for my own sake. I have z squared, which is my hypotenuse, which is 1 squared minus 1/2 squared. Okay, so to keep progressing with this, we have the square root of 1 squared is 1 minus, now if we work our way over here, 1/2 squared is the equivalent of 1/2 times 1/2. So multiplying fractions, we have 1/2, or 1 times 1 is 1 over 2 times 2 is 4. So 1/2 squared is equal to 1/4. So we have 1 minus 1/4. Okay, well, 1 minus 1/4 would be, we still have our square root, would be 1 minus 1/4 is 3/4. So now to simplify this, we could actually simplify this and say, well, that's the same as saying the square root of 3 over the square root of 4. So we can simplify this one further step, and we get root 3 over 2. So now, this isn't necessarily exactly where this root 3 comes into play. It is part of it, so that'll be the next video. But what we've just isolated is that this is my horizontal component of this phasor of 1 and 0. At this placement, when the horizontal is 1/2, the hypotenuse is still 1, the horizontal is 1/2, the vertical is √3/2. So I'm going to end this video here. If you need to kind of digest this a little bit, we're going to get into the next video of where the √3 relationship comes into play for us next. I hope this has helped. If you've got any questions, you can post it below, and we'll see you in the next one.